Okay, brake release. Airspeed's alive. Nozzle steering's off. Looking good. Pulling right. And 143. Airborne. Letting the gear down.
We got a lock, please.
Okay, clear chase.
Clear chase.
Sport, S859, airborne passing 5,700.
S859, Sport, radar contact.
Drastic variation. Thank you.
And control is ready for takeoff.
Six, 7, 8.
30, 40, 150, 160. Leaps right off the ground. Decast up. The nose up to keep the airspeed under control. There.
7 miles off direction, 10,000 to T7. He'll be at or below 10,000.
Heavy control rolling out here to the east.
There's full right pedal. Sliding out for pickle.
In the room, thumbs if you're good for the gear retraction.
JJ, all ready.
Ready.
Gear in 3, 2, 1, now. Okay, it does pitch up a little bit. Hold speed just fine.
Clear dry.
Settings are verified. You are clear to arm and run.
It'll turn into us, bank away.
Run. Unpotated, 2 potato.
Point complete. Stand by reviewing.
Clear down and run.
Run. Unpotated, 2 potato.
Point complete. Stand by reviewing.
You're cleared left side slip, slow release.
Copy left slow. Left. And easy. Half. 3/4. Full. Slowly backing out. Quarters. Half. Quarters. Release.
Point complete.
Test control. Good maneuver, card complete, moving to card 5, set up for climb, up to 32K, 0.7, target 241 keys. Copy.
Control is ready for the climb at 250 to 260, capturing point 8.
Okay, test copy. Starting up. 250 to 260.
And test, expect potential wind shear in the 12 to 14K region.
Copy.
Chase is showing 291, 32060.80 Mach.
Copy, ready to go to 43K.
Okay, coming up to 43K.
Okay. There's 43K.
Clear to excel.
Chase Mippling, 0.94, 0.95.
Test, you are cleared. Roller coaster.
Roller coaster. Rolling over.
Point complete. Point complete.
VRF, give me 10. Get the FDS, get it down the flaps, we'll check that. We're probably this fuel right now is on 85. Okay, let me go ahead and reset bingo to 2.7.
Copy, resetting bingo.
So we'll call that Joker. Okay, red light handle, brake to grade. Green, FBS coming out.
Control shows program 5 in progress. Test control enable. Fuels request, cross feed valve closed.
S859, contact tower 2.
Foot.
NASA 859 flight, runway 23 left 1, column clear for the option, traffic follows on short final full stop.
Inside, yeah.
NASA 859 flight, runway 23 left 1, 1103, clear for the option.
A little crosswind, maybe?
Good transition. Good transition.
Thank you.
The big successes from Block 1 were getting the airplane airborne again, retracting the gear, showing that it flies well with both the gear up and the gear down. So we started off Block 1 with just one flight in the first week, and then we worked up to 2 flights in the same week. We've now worked up to doing 2 flights in one day and up to 4 flights in a week. This flight test is all about a build-up approach. We don't want to just go out as fast as we can on the first try. So we step carefully, we go a little bit higher, we go a little bit faster. Each one of those test points expands the envelope. We also go slower and lower because sometimes that's a little more hazardous. So we get the airplane to its minimum speed, and we've achieved that as well on Block 1. For higher and faster in Block 1, we got up to 43,000 feet and about 0.96 Mach. The next step in the next phase, of course, will be taking it supersonic. So the flight test maneuvers we do, such as bank-to-bank rolls or side slips, are all designed to prove that the airplane is safe to fly in a normal envelope. Down the road, when we're flying it around the country, we don't have to worry about whether I can roll to the left and pull hard on the stick. All these things have been proven in flight test with a control room backing us up the whole way. So we've spent years flying our simulator, so we have an idea how we think the airplane's going to fly. From a handling quality standpoint, it feels a lot like the simulator. Big difference is the simulator doesn't have motion, so now we get to feel all the motions of the aircraft, the oscillations, vibrations, things that you get in a real airplane. Performance-wise, our airplane actually seems to be going faster and climbing better than the simulator even predicted. So that's exciting news. Every time we go fly this airplane, we learn more about it. We learn something new. We also just learn how to be more efficient. So our maintenance crew is getting very familiar with the airplane. They're able to process the airplane after landing and turn it around for the next flight in shorter and shorter time spans. So during envelope expansion, every flight we go out and we do something that hasn't been done yet with the airplane, and those are the test cards or test points that we're trying to reach. So every day we prove something new The airplane can go higher, it can go faster, or it can go slower, but everything we're doing is new, and that's the point of envelope expansion. And once we've expanded the envelope and there's nothing new left to do, then we're done and the airplane's ready to go.
The success of Block 1 was expanding both in altitude and airspeed to prove out the system performance and as well as the vehicle handling qualities, and validate that it's matching predictions to give us confidence to proceed even further in speed and altitude as we proceed into supersonic test flights. Yet to prove the airworthiness and handling qualities of the aircraft at each test point along the way to give you the confidence that you can continue to expand to both higher and faster speeds. Milestones accomplished in Block 1 include flying up to an altitude of 43,000 feet, reaching Mach 0.95 just before supersonic flight, landing gear transitions to prove the airworthiness and the vehicle systems both in the up and away configuration with gear up and the landing gear down configuration. We're doing maneuver development sessions to make sure that the pilots and the test team know how we're going to go fly certain maneuvers for an upcoming mission. We have sim rehearsals in the control room to make sure the control room team is fully trained. The maintenance crew is making sure the jet is completing all of its routine inspections and making sure the jet's ready and airworthy to fly the next mission. We have the flight test engineering team putting all the products together to go support the actual flight test in terms of briefings and test cards. And then we actually have the day of execution where we go through briefings and the flights themselves and the debriefings.